All right. Good morning, afternoon, good day, good morrow, whatever, to all you little people out there. We are going to move on from slope-intercept equations, which I'm sure we're so happy about, and we're going to move on to one-step equations, which is something you should have learned in sixth grade, and then we're going to move on to two-step equations, which is seventh grade, blah, blah, blah. Let's go ahead and just jump into these terms that we need to go over really quickly, so that we are ready to go. No time wasted. This should be pretty easy. So this first one is expression. Expressions do not, oh, this is bad, have an equal sign, okay? Oops. Ugh. Expressions do not have an equal sign, all right? Reason is they are a group of symbols, numbers, and operations, okay? They're a group of symbols, numbers, and operations. So that could literally be so many things. It could be like 4x plus 2, no equal sign. It could be 2x to the 5th power. It could be 5 over y. I don't know, right? I don't have any space to write that, so I'm going to leave it. But as long as it doesn't have an equal sign, right? So things that are non-examples are like 2 plus 2 equals 4. Not an example. What if I said y equals 3x plus 5? We've seen an equation like that before. Not an example, okay? So even like something like 2 over 1 equals 2, not an example, okay? So expressions are just these things without equal signs. So an equation, of course, does have an equal sign, right? Does have an equal sign. So it is a statement. Oh, I just wrote A twice. A statement where two expressions are equal. A statement where two expressions are equal. So that could be y equals 2 over 3x plus 5. That could be 3 plus 1 equals 4. Like, right, it has to have an equal sign. So things that aren't going to count are things like, oh, I don't know, 7 to the 2nd power. Or 5x 3y 7. They just don't have equal signs. They're not, nope, absolutely not. Okay? Now, inverse operations are opposite operations that undo each other. Okay, opposite operations that undo each other. So if I'm looking for an example, let's think about addition. What's the opposite of addition? Subtraction, right? Okay. So what would not be the opposite of addition? What would not be the opposite of addition? Well, addition is not the opposite of addition. It's the same thing, right? Multiplication is not the opposite of addition, and division is not, right? There's only one opposite. So that being said, these are our operations and their inverse. So addition, the opposite is subtraction. What's the opposite of subtraction? Addition. What's the opposite of multiplication? Division. And what's the opposite of division? Multiplication, all right? Cool. All right, cool. So we've got all of those notes down. Let's move on to some examples of these one-step equations. So I'm just going to go through 4 of them quickly. The first one we're going to look at is, sorry, I need to look at it. 41 equals 30 plus r. So our goal when we are solving equations is to isolate the variable. Now, isolate means that we want to get the variable by itself. Okay, our goal is to get the variable by itself. So what we're going to do is we are going to draw a line. Oh, I don't want to click that, sorry. We are going to draw a line in between these two sides of the equation through the equal sign, just so I can have a division of my left side and my right side, okay? And I want to look at the side that has my variable. Now, once I identify my variable, okay, so first step thing I'm going to do is draw a line, okay? Step 2, I identify variable. So I ID variable. All right. Now, once I ID the variable, I want to kind of think about what operation is happening on this same side of the equation as the variable. What's happening between the variable and the number that's on the same side? So I'm going to think about what operation is happening. So the operation currently. So what's currently happening on this side? Well, right now we're adding, right? Cool. That means I'm going to do the inverse operation. Okay? So the R I'm just trying to keep by itself, but the 30, is that a positive 30 or a negative 30? Does this plus sign go with the 30? No, this plus sign goes with the R, right? It's whatever's in front of it. So in this case, this is a positive 30, so we just don't see the plus sign. So in order to do the inverse of positive or plus, I have to subtract 30. So I'm going to subtract 30 on both sides. These 30s canceled, and I'm left with 41 minus 3. So this is 1, 1, and I bring down my R, and now 11 equals R. So that is an example of addition with a variable. Okay. All right, let's do a couple of other ones. Let's look at, how about negative 2 equals k plus a negative 10. All right. Negative 2 equals k plus a negative 10. So I'm going to, again, my goal is to isolate my variable. I'm going to draw my line, right? Now, if I look at this same side, yes, I have a plus sign, but I also have a negative sign here, right? And so, yes, we're looking at what's in front of it, but immediately in front of that 10 is that negative sign. So currently, this is like a negative. Oops. This is a negative or subtraction, right? So in order to do the inverse, what am I going to do? I'm going to add 10 to both sides. Okay? So these 10s cancel. I'm going to bring down my k. And now, negative 2 plus 10. So think about it. We've got, these are opposite signs, right? Opposite signs, and we take the sign of the bigger number. So if they're opposite, we subtract. So 10 minus 2 is 8. I take the sign of the bigger number, so it's going to be positive equals k. These are really quick once you identify what's going on. Okay? All right, and we're going to do 2 more. My first one that we're going to do is negative 42 equals negative 3x. And the second one we'll do is b over 3 equals 15. Okay, so for this one, I'm going to draw my line. I'm going to look at my variable. What operation is happening between my variable and the number in front of it? Well, right now it's multiplication, right? What is the inverse operation of multiplication? Well, we've done this so many times, right? The inverse operation of multiplication is division, so I'm going to divide both sides by negative 3. These 3's cancel, right? Negative 3 divided by 3 is going to just give me a 1. And now my variable is isolated. I just have an x. And then I have to do 42 divided by 3, but really quick, let's think about cute little Dorito man, right? We love him. Okay? Negative divided by a negative is a positive, so my answer will be positive. And I actually have to do 42 divided by 3. 3 goes into 4 once. 1. 3 goes into 12 4 times. So 14 equals x. Amazing. Chef's kiss. Okay, last but not least, this is an example. Well, let's look. What operation, after I draw my line, is happening between the b and the 3 right now? If you don't know, what did we do over here that looks the same? Division, right? So we're dividing, which means I have to do the inverse, which is multiplying. So I'm going to multiply both sides by 3. If you multiply by 3 and divide by 3, those cancel, so I'm left with just a b, and 15 times 3 is 45. And that's it. Okay? Hopefully this is helpful. I actually think two-step equations, what we'll do next class, are a lot easier than one step. So good luck to you.